Stop using the update method to constantly poll for mobile touches and mouse clicks. In this tutorial, you're going to learn how to build a fully cross-platform drag and launch mechanic using Unity's new input system, built entirely on clean, high-performance C# events. Click on the Window menu, then go to the Package Manager. From there, change the Registry dropdown to Unity Registry. Search for Input System, and install it if it isn't already. Once the installation is complete, search for 2D. This includes all the sprite dependencies and other related packages we're going to need later. Go ahead and install it if you haven't already. Now, click on the File menu and select Build Profiles. From there, select Player Settings and jump down to Other Settings. Under Configuration, look for Active Input Handling and select Input System Package, New. Now, go to the scene, and under the Hierarchy window, select the main camera. In its Inspector window, go to Projection and change it to Orthographic. Right-click in the Hierarchy window, select 2D Object, then Sprites, and select Square. Rename it to BG. Set its position to 0, 0, 0, and its scale to 30, 10, 1. Change the color to light blue, then click on Sorting Layer and select Add Sorting Layer. Add a new layer, rename it BG, and select it. Next, create the ground by right-clicking in the Hierarchy, selecting 2D Object, then Sprites, and choosing Square. Rename it to Ground and change its color to brown. After that, create a new sorting layer named Foreground and assign it to the Ground Game object. Now, set its position to 0, -2, 0, and its scale to 30, 1, 1. Finally, add a Box Collider 2D component to it. Next, create a circle sprite and rename it Player. Set its color to red and change its sorting layer to Foreground. Then, add a Rigid Body 2D component, followed by a Circle Collider 2D component, and move the collider above the Rigid Body 2D. Now, let's create an input action. In the Project window, right-click on the Custom Input Action folder, go to Create, select Input Action, and rename it to Game Input. Now, double-click it to open the window. Click on the Action Maps plus icon, then select New Action under the Actions panel. Set its action properties, and under that new action, select No Binding. Next, let's add a binding by clicking its plus icon and setting its properties to touch screen, then press. Finally, rename it to touch. Then, create a new action by clicking the plus icon and set its action properties. Change action type to value and control type to vector2. This will act as our position tracking. Underneath it, add a binding and set its properties to mouse, then position. Next, add another binding by clicking the plus icon, choose touchscreen, and select position. Now, rename the action to touch position, and then click Save Asset. Now, select the Game Input Action asset and check Generate C# class. This will create a basic wrapper class for our input, which we'll use in our script to handle inputs. After that, click the Apply button. Let's add some sprites to the project by creating a new directory named _sprites and importing them using drag and drop. Then select both of the imported images, go to the inspector, and set the texture type to sprite, 2D and UI, and the sprite mode to single. Once that's done, click the Apply button. Now, let's apply the newly imported images to our ball and set up a basket at a specific height as a target. To do this, create a new 2D square sprite and name it Basket. Then, apply the basket sprite to its sprite renderer component. Set its scale to 0.05, 0.05, 0.05, and its position to 10.14, 2.570. Next, add a box collider component to it and position it along the upper edge. This will allow us to calculate the score only when the ball passes through the top of the basket later on. Now, let's import the script that I've already created into the project, and then we'll open it up to resolve any errors. In the script, I'm creating a game input variable named input so we can access all of its properties. Now, as you can see here, input.player isn't actually available. That's because, in the input asset we created, it's called player input. We can easily fix this by changing input to player input and saving the script. Now, we only have 2 warnings left, and they're just letting us know that rigid body 2D dot is kinematic is deprecated. We can easily fix this by adding rb.bodyType equals rigid body type 2D dot kinematic. Let's save the script and check if that clears it up. Bingo! All of the errors and warnings are completely clear now. Instead of using the update method to constantly check for mouse clicks, we're leveraging the new input system's event system. By subscribing to Started and Cancelled, our code remains completely asleep until the player physically clicks or touches the screen. This approach keeps idle overhead at 0 and saves massive mobile CPU performance. The most important part of this script is how we calculate the world position. Because screen space is 2D and world space is 3D, passing a raw vector will completely break your physics. To fix this, we inject math.f.abs, open parenthesis, main camera, dot transform dot position, dot z, close parenthesis into our screen position vector. This gives Unity the exact depth context it needs before converting everything into world space. Let's add this script and the line renderer to the player game object. Then, assign the line renderer component to the ball slinger script's line renderer variable and set the force to 5. Now let's click the play button in the Unity editor and check. Oh, looks like our player is intersecting with the ground. Let's fix that by resetting the Circle Collider 2D on the player game object. Let's check it again by pressing the play button. There we go, it's fixed now. Next, let's click on the ball, drag the mouse, and release. Perfect, it works. The ball releases just like a slingshot when we let go of the mouse. And there you have it. A fully cross-platform, event-driven drag and launch system that works seamlessly on both PC and mobile devices, without using a single line of code in the update method. If this tutorial helped you clear up the confusion around Unity's new input system, please smash that like button and subscribe to the channel. It really helps a small channel like this grow, and it tells me what kind of tutorials you want to see next. The complete clean C# script is hosted online, and you can grab the link directly from the description below. If you hit any roadblocks or have a question about setting up your action maps, drop a comment down below and I'll help you out. Thank you so much for watching, keep building your games, and I'll see you in the next video.